Welcome, ladies and gentlemen. Yeah, I don't have any more else to say. Hello, everyone. My name is Biz, and welcome to the stream. Today, we have to make a few things. First one, fuck. Okay, today, first of all, we'll hope that the stream doesn't fucking crash. That's the first thing. Secondly, we need to make a compiler. And fun fact, I've already started. I've already started a little bit, but I want to expand this a little bit more. And actually maybe even also change it a little bit. Let me just get all this away. Hide the evidence. That's a simple CPU language. This is compiled CPU language. Yeah, that is the language name, okay? Compiled CPU language. So let's actually really quickly just change everything. And when I say everything, I mean everything. Why the fuck? Oh right, yeah, I forgot. I am now running on a pretty strict rule set of variable naming, because I need to get some fucking practice in that. So if I look into here, we have a whole bunch of things here. Actually, I think this one I can just delete, because I don't want to like have a dot underscore s. And it's still there. Why? Fuck. There's nothing about that now, but what if we just just build it real quick? Well, let me just still ns underscore. Well, fuck that then. This will have to be an m underscore right there. Also, why is this one even s underscore? Oh yeah, that's why. Wait, good. Right, so yeah, this is the thing. This is our entry thing. We have a way to set CPU type and all that, which actually also need to get. Actually, let's really quickly change that before we do anything further, because as you guys can remember, I changed the whole CPU structure to now be architectures instead of instead of being dedicated CPUs. And I really quickly need to do all this. Right now. Okay, so now how was the CPU thing again? It was the BC018, the BC116, the BC224, yes, and then the BC. Actually, you're gonna go right there. Sorry, I needed to put my phone somewhere. And then the BC232. BC 0, what was it again? 018. BC 116. The BC 224. And then the BC232. Okay, so now we've got that. Okay, so this is where all the magic happens. And what I'm thinking is that instead of doing this with parsing, what the fuck was that? Huh. So instead of converting everything into nodes, I probably want to like do what's it called? Just generate the code here instead of do a parser and then a generator here. So yeah, let us really quickly rewrite the whole fucking parser. This one needs to be thank you. Alright. So normally in a program, in a compiler, normally in a compiler, you will of course have the tokenizer that tokenizes everything into different tokens. Then you would have the parser defining the syntax here and putting all the syntax into a parser tree. And then the generator will have to go through that parse tree and generate the code. Now we are going to do it a little bit different because I can't be bothered doing anything with fucking parsing. So we are going to be doing that. We're going to actually be doing all the generation here also. Yeah, we'll have to make a list of strings. Let's call it the m underscore output. Okay. Okay, so yeah, now we don't need any of this. Actually, what? Yeah, we just need to do this and then this. We need to make this into a void right here, and just do a return here. Now, this will also have to be gone. All of this, and these two. Now we'll have to go into the things themselves here, and individually say, you are no longer this. And say that, for example, you are also no longer this. So this one, I think I want to really quickly save. Alright, so the reasoning I'm doing this is because that what's it called? Everything everything here sorry, the language will be more will be closer to the assembly language, so it will be on a whole different level in terms of like in the terms of like in terms of where the language is as a whole to the according to like everything, according to like how can I say this? Okay, so the way the x86 architecture, for example, handles with all this is by doing by having, for example, so we all know that the assembly, it's at the lowest level. You can't go any lower, or yes, machine language, but you don't want to be writing zeros and ones. Have prior experience with that. So yeah, you don't want to be writing out the machine code itself. So assembly language for this example is the absolute lowest level you can go in the language department. Now, let's say on top of that, on top of assembly, you have, for example, a language, for example, Fortran, that is a little bit higher level. You have more, you have less memory control, and more functions that are readable. And on top of that, you have COBOL's not readable, C, for example, which is again still low enough to call it low level, but it's more readable than assembly, and so on and so forth. So you have these kind of, what can you call them? Like, you have these levels, as I've already probably said before, that are, yeah, there. Yeah, this language here will be pretty much just on top of assembly. And now it's time that we need to figure out how the syntax will look like. So beforehand, you could see that it was much more like C orientated. Now, I want to pretty much just like have this, but have some words here that help a little bit more. Also being able to have basic low level stuff here. It should probably be m underscore main underscore there. So this one right here will just simply be an assembly inlined. Now you can access the registers, for example, using %, and say A, for example, and then set it to be test. So you don't have to do the hard, like you don't need to go all the way down, but this is just a step up, for example, from assembly, machine code to assembly. This is just only a small step up to make it more readable, and probably also easier for the programmer. Now, Now if we have test here equals to percent %a, this will set test to be the value that is in A, which beforehand we just simply said, for example, that A is 55AA. So now test is 55AA. And so on and so forth. So let us have ourselves a very simple program. Main return 0. So this will return of this function here. Now, the thing is, how do we say that it actually returns something? Probably by saying, for example, type name. What about arguments? Well, I think I'll come back to that one. But now we got at least the main principle. Now I need to check out the tokenizer because I think we need to change some things here. Yeah, we do. So byte s byte, just because it's cool. Okay. Now why the fuck do we use this? Oh, there. Yeah, so this one we will not use. LT byte or ST byte. Even though you're probably not, I'm gonna remove that one. And then you have int s int. And I also want to have the word and SD word. We already have assemble. Do we have a colon? Yeah, yes, we already have a colon. Goodie. So that should be it. At least for this. Now if we really quick build it. Right there. And I can see some things here. Really quick can change. Okay, so now we should have all the tokens in a token.test. So yeah, we have a uint byte. We have an identifier main. We have a colon. We have a return, and then we have an expression called that is 0. Int literal, that's a 0, which I will call expression or term, sorry. Now in the parser here, we'll say if is type and peak 1 dot as value and peak 1 dot value dot type equals to be an identifier right here. And then a colon. Now this will declare a function, so we'll say parse declare function right here. Now this is all not good anymore. This is no longer anything that we can use. So I'll delete that. Then I think we can say something like get type. That was not mine. What was that? That was parse type. So we'll say parse no, didn't I have a type? Parse type? Oh, I have a parse size. And then we'll say, and we'll give it a name. Try consume error. A token type ident. That value. And then we can say try consume error colon. Right here. So now we have everything that we need. Okay. So in the assembly, we'll now write. Actually, here I want to transfer something from over here, because in here we had a function called add line. Let's really quickly add this one. Which will take in a section and yeah, run with it, I guess. So m underscore output, because then we don't need to think about what kind of section or anything else things are at. So yeah. So now we can say in here, over here, we can now say that we have an underscore main there. Now are we also in here thinking about publics or no? We are not. Okay. I guess that's fine enough, because yeah. I think I'll think about how we can do this later. But yeah, this one I also want this one will have to be, and also I need to do the add line function, not ling. Line with an fucking e there. Declare function underscore name that returns a that returns bytes. Now let's see how badly this can go. Oh right, yeah, I forgot that I also had made a return here. So let's really quickly just also get that one. And now the output, if I'm not mistaken, is not that one. Is it ACL? Yeah, it's in there. Yeah. Declare function main that returns 1 byte. Of course, we could also do void and return 0 bytes. But yeah. Now this return, let's do that one next. Now return. Actually, here we need to change the whole parsing thing here. Dot value. And then the rest here will just have to be scored on the motherfucking... Oh fuck, there's a thing in here that fucks everything up. Here. Right here. This one, actually, this parse expression here will actually not do return anything. And now we don't do expressions any longer. And actually, let's actually make a whole new algorithm here. So yeah, let's just make a whole new algorithm. Right there. Parse pointer. Okay. Okay. Right there. Good. Now where the fuck was that? Okay, so return now an expression where we'll say parse term. Not as line. He typed as line. Move a right there. And we can just say return 0. For now at least. We'll have to come back to this one. I think this one we can just delete, I guess. Now, else if peak value equal, not question mark, but equals to return, then we can say parse return right down. And we, in some way, we fucked it up. How? Oh, that's why. Apparently, apparently void is not a term. So, and it's not a size, sorry. So let's really quickly do that. The size equals to 0. Okay, so why not? Oh no, wait, two things. It's all these up here that we need. So if it is unsigned, it will be 1 in size, 0 in size. Right there. And look at this. Now we have a 0 and then we have this. Okay, so now we can actually begin to do shit. Mainly what we can do is begin to actually make some variables. Now, I think the way that I want to make a variable is quite ordinary. Just like this. Just like the old way of, doing it. So here, declare a variable. We no longer have colons or strings. So we'll get the size, we'll get the name, we'll get this one, and then we'll have to do the expression, which will now be a string, and where we'll say parse term. Right here. That was everything. Add line. Okay, now we need to figure out how we're actually going to be making use of variables. Okay, a way that we could do it is to make a dedicated space for each variable. So move 7F00 with 0, for example, or AL, or maybe just 0. Have a dedicated space for each variable. For example, in the section BSS, we could do this, or we could, if we want to be dumb in some way, shape, or form, or maybe not dumb, but yeah, we could say move A with 1, with 0, for example, and push A. Now, why do we want to push A, for example? Wait, that's because that when we then want to actually get it, we can then say SP minus. Actually, that is. Did my stack go up? My stack goes up, I think. So it is minus, yeah. -1 to get this one. Which this number will then have to be doubled to actually get the whole thing. Because we are running in a... I think this compiler will be a 64 bits one. So yeah. Either that, or we'll have to like either this, and then we can use some complex math to get it. Or like this. Which if we use this, we can more easier integrate it with, for example, the rest of things here. And we get more space on the stack for different things. So we are going to use a BSS route. So let's add another one of these and then call it BSS. And down here, we'll now have one of these. This one. Okay, let us do one thing. So let's make it so that all bytes gets promoted to a word. Like this, for example. So instead of saying .reserve byte, we'll say reserve word. The reason I want to do this is because I can't be bothered to do all that. So yeah, here we can now say is type. Now, if it is a type, we can then ask, does it have a value? If so, want to get that value and check is an identifier. Now we can't just stop there, because we also now need to check number 2 if it has a value. If yes, number 2, the value dot type equals to an equal sign. If it is an equal sign, then we can declare not a function but a variable, which looks for a type, looks for that, looks for an assignment operator, and there. Great. So now we want to say move a expression. Then we want to move what the fuck? Now we want to move using the name as a basing point. Want to move that, want to move a into that. And then in the add line, want to then say right there, add tab 0 and then section BSS. And we want to say how big is this type? And again, we have made it so that these ones now are words instead. I don't know why I just did that. But yeah. So now we can then say type underscore type, and then say type size. And then we can say dot reserve that amount of bytes. Now, the way that we got all of them over was by doing that. So here at the end, I want to say add line. Want to give it an environment, not an encoder, but an environment dot new line. And want to say dot section BSS, right? Real quick, want to do that. And then we want to say m underscore output dot add range. And we want to say m underscore output BSS. Okay. And we have and we just have an identifier. Yay. Why the fuck is that? That's why. That's because we also. No, wait, 2 seconds. Oh. That's why. So when we need to declare the variable here, we need to say dot value, and then right here. Okay. So that is it right there. And now we have an underscore there. Takes up to 2 bytes. And we are loading A into it. Gucci. Okay, that was an easier part. 2 things again. Did we for example have things like public here? Nope, we did not. Okay. So yeah. What shall I now do? Might have been an update there. Okay. Okay. Let me see. So now I have all that. And now if we, for example, do a u short u test equals 0. It's also just that. A t byte and an int t test equals 0, I test equals 0. I know all this just seems for 0, but hey. And this one reserves 2 bytes, and this one reserves 4, which an int should also reserve 4. Gushi. So now we have that. And I want this to be easily integrated into our program that you have in the assembly part, so I won't do this too much. Okay, so now that we can do that. Now what does it actually say? Yeah, it says that. Now, what happens if we try to reference one of those? It will probably not work. So let's really quickly make it work. And I kind of want the syntax to be using open square. If we have an open square, then we can immediately consume it. Then we want to have a name of some kinds. So I consume error, ident, the value, and then I wanna try consume error, close square, and then we want to do name here, and do that. So that should now not work. That's because we only had the identifier. Now, I think either I want to do it like this, reference it using this, or shall I? Okay, yeah, I'm just going to do it the boring way. Nothing at all. Now we are referencing this one, but it needs to be in quotation marks, not quotation marks, in square brackets, because else the thing, the assembler will think that we are trying to reference the memory address of it, and not try to reference what is in at there. We could probably make an optimization here. Also, it doesn't need to be underscore. We need to have the underscore. Right here. So yeah, like this. Okay. So now I have that. Now we are declaring a0. Then we are declaring a new variable here of 2 bytes and plumbing that and returning with it. All of this using 10 lines of assembly shrinking down to 3 lines of my compiled language. I will say that that actually goes pretty good right now. Now I want to do one thing real quick, and that is to use my fine dandy calling convention. Okay, so We are working, yes, great. Okay, so okay. The thing here. Okay, we need to push R, but before we push R, we need to enter and then push R. Now, what enter does, the instruction enter, that makes a new stack frame for us. So pushes BP and sets BP to SP. And push R just pushes all the necessary registers, so A, B, C, D, H, and L. Now, when we need to get out, we need to do a leave here. Okay, so just like that, we got it. So now we are entering a new call stack, and actually also I forgot to say pop R and then leave. Now there's a little thing here, because test is a local variable. It's a local variable here, so technically we shouldn't actually be using test, but technically we shouldn't be using the BSS to that. So we'll have a variable, or actually not a variable, but a stack of ends, not nits, but ends, that we will call up here somewhere. M underscore scopes. Now these scopes will say a lot of things here in a few minutes. But let us really quickly make ourselves a few things. Let's make ourselves a few variables real quick. We will make ourselves all of these variables. They'll pretty much do all of these things for me. All these functions for me. And we'll do this one. Now this m underscore variables va m underscore var right here. Another thing that we also miss is this stack size here. Yeah. Okay, and struct var Okay, so we also will get this one real quick. We will not actually make it public like that, so okay, so okay, yeah, we also have one. Right here, right here. Now, which button was that? That was F3. Um, and right down. Okay. We will really quickly do this one, just to please everything. Okay, and of course a failure because that this one needs to be down here. Right there. Make a field right there. And then rename. Do not do that, but I said fucking rename it. String. Error exception. Okay, right there. Alright, so now we have everything. I think, yeah, I think this is going to be a fucking short stream because I'm fucking tired. So yeah, yeah, I am actually fucked up, fucked up. Huh? Yeah, you can just hear it. Well, thank you all so much for watching the stream. May you all have a fantastic day, and I'll just say see you all next week. I think. I can't actually remember when I fucking stream again. Right here. Yeah, okay. And is the sound on? Yeah, that is. Okay. Fuck. Okay, when is my next stream again? My next stream is probably actually going to be next week. Maybe Wednesday. Maybe I'll have to do a more. I should have to define my like schedule at some point. So yeah, but yeah, be on the lookout for my schedule if it changes. So yeah, yeah. Goodbye.